Alright, today we're going to talk about the difference between weight and mass. And something else I want you to make note of, that weight is a specific type of force. We call it F sub g, or the force due to gravity. Okay? So, let's start by discussing the difference between weight and mass. Weight is measured in newtons. That's the metric system. You guys are probably used to hearing it measured in pounds. That's the English system. But in metric, weight is newtons, right? So you can convert pounds into newtons. It's also the fact that weight is dependent on gravity. So if gravity changes, weight will change. All right? If you remember, gravity is an acceleration. All right? And since weight is a force, F equals ma, if you change the acceleration, you will change the force. Okay? Whereas mass, on the other hand, is measured in kilograms, and it is not affected by gravity. So mass is the same whether you're on the Earth, on the Moon, on Jupiter, wherever. Okay? Your weight, though, changes based on planets. So just keep that difference in mind. Weight is a force. It's a specific force related to gravity. Okay? So let's talk about this a little bit more. So the force due to gravity, also known as weight. Notice, sorry about the bells. Notice that the force due to gravity and tying it to weight is said several times throughout here. I can use both words, and they mean the exact same thing. Okay, so F sub g is equal to weight. So, just so that you can see how this comes from our force equation, F equals mass times acceleration. All right? These two can represent the same thing. F sub g is equal to weight. All right? So what I would do is just focus on this part. Weight is equal to mass, and then you plug in a very, very specific acceleration known as gravity, which is why we labeled it as g. All right? So weight is equal to mass times 10 meters per second squared. Again, we will use 10. Technically, it's 9.8. We'll use 10 just because it's really easy to multiply by 10. You should be able to do that in your head. All you do is move the decimal over 1. Okay? So, the final derived equation is weight equals your mass times gravity. All right? Let's apply this to a problem. And this problem is a review. It's a little bit of both. You apply a force of 10 newtons, so we know F equals 10 newtons, to a 25,000 gram object. All right, I underlined the gram for a reason. What do we have to do? I hope you are saying convert it to kilograms. All right, so mass is equal to, there are 1,000 grams in 1 kilogram. So we divide this by 1,000. Okay, so we have 25 kilograms. And then the first question, what is the object's acceleration? So the equation we need is force divided by mass. So that's going to be 25 divided by 10, or 2.5 meters per second squared. All right, the second question is, what is the object's weight? So some of the information we need, some of it we don't. So we know the same information from before, so I'm not even going to rewrite it. All right? But weight should automatically make you think of g, 10 meters per second squared, or gravity. All right? So in this case, your equation is W equals mg. W equals 25 times 10, or 250 newtons. Okay? So there was the answer to the first question. There's the answer to the second question. So just keep in mind, weight, you must use gravity as your acceleration, right? And also, please don't start thinking of gravity as a force. Gravity is still an acceleration. There is also a force named based on gravity, or the force of gravity, okay? But the force of gravity is caused by the acceleration of gravity. Hopefully that didn't just confuse you more. But just keep in mind, gravity is an acceleration and can be used to create a force if you also have a mass. So make sure you do the online form, and I will see you in class.